One girl left. Okay, let's continue. Today there won't be much of class. We have to discuss a few little topics before we enter into HDFS, how to distributed file system. We need to know some basics regarding file systems and blocks in a hard disk and the replication factors. Today we are going to cover these three topics. Okay? Yeah. Actually, first let's see the versions of Hadoop. Hadoop 1.x initial release is Hadoop 0.x actually. After that they came with Hadoop 1.x, which consists of HDFS and MapReduce. Storage part, HDFS is meant for storage part and MapReduce is meant for processing part. Initially Hadoop 1.x has these two components only, HDFS and MapReduce. Later they introduced Hadoop 2.x with another component called YARN. This is for resource management actually. We will store the data in HDFS, we will process using MapReduce. But to optimize the usage of resources in a cluster, in a set of systems, there is a need for a management software, management component, that is only YARN. YARN improves the performance of Hadoop cluster. That is a major change between Hadoop 1.x and 2.x. Recently, 1 month before, they released a new version of Hadoop with 3.x. What is this .x in the sense? Hadoop 1.0.0, 1.0.1, like that. I simply calling it as 1.x and 2.x. And one important thing to note, I am telling you regarding Apache Hadoop only. I think you have heard about Cloudera Hadoop and Hortonworks Hadoop. Yesterday I told in the distributions part. We are not going to discuss those Cloudera Hadoop and Hortonworks Hadoop as part of the course, but I will give a brief idea after finishing the course. The main thing, important thing which you have to know is you have to learn Apache Hadoop. That's what we are going to cover. That is the basic thing. If you won't learn Apache Hadoop and if you directly jump into the Cloudera or Hortonworks distribution, you won't understand anything. You don't know what to do if the issue arises in the project. You don't know where to correct, where to go, where to see the log files, where to correct the issue. You don't know that all. All those can be learned through Apache Hadoop. So this is the basis, Apache Hadoop. Okay? That's why I'm telling you regarding Apache Hadoop. Let's say a brief overview of HDFS. HDFS is a file system responsible for storing the data in commodity servers, in hardwares, in nodes, in different systems in a cluster. No matter how many systems, how many machines are there in a cluster, in a group of, in a network, on top of all above those, on top of all those systems, we will have this kind of file system. It is a file system. Do you have any idea regarding file systems? Even in our laptops we have a file system. Even in pen drives, everywhere. In order to store the data, we need a file system. Anyone have idea regarding file systems? Just a brief idea, even if you heard. Okay, let's see. There are lots of file systems actually, not only these three, lots of file systems. But we have to know these basic things. These are important for us. With respect to Hadoop, first let us see what is a file system. File system versus distributed file system, then Hadoop distributed file system. I am taking you step by step. First file system, then distributed, then Hadoop distributed. Our target is HDFS. We have to know regarding Hadoop distributed file system. So we have to know something regarding what is the negatives of file systems, existing file systems, and distributed file systems. We should not bother about remaining file system, network file system, exFAT. A lot of the file systems are there like that. So what is a file system actually? The way in which the information on a storage device like hard disk is organized is termed as file system. Just try to understand the meaning. We have hard disk in your laptop. Maybe the capacity is 500 GB, 600 GB, 1 terabyte. You have lots of files in your hard disk, lots of files in your system. But when it comes to Coming to hard disk, coming to physical storage, how those are bits are how those are arranged in the hard disk. Every information in the form of zeros or ones only, right? Even it is a movie file, audio file, text file, any kind of file. We simply have zeros or ones in the hard disk when it comes to physical storage. But there should be a proper mechanism to adjust, to organize those bits on a hard disk. That part will be taken care by file system. Understood? Everyone?
Yes.
Yeah? You have a brief idea about file system? Suppose think you have 1 GB file. Are you facing issues, guys? No. Yeah, Madhuri left hand joint, Sarjan you also left hand joint, okay.
No, I'm there. Aujin, I'm there.
Yes, okay. Don't worry, anyway I'm going to share this class after the, share this online class after the class. Okay. Have you got the brief idea now regarding file system? What is a file system?
Yes.
Yes, the way in which the bits, physical bits, zeros and ones are arranged physically on a hard drive, they are arranged in the form of a blocks. No matter how much your file size is, think your file size is 1 megabyte. 1 megabyte. So 1 megabyte of the content, the content which is equal, zeros and one contents which are equal to 1 megabyte are arranged physically on a hard drive. Yeah, I muted every one of you. So that part, that mechanism is taken care by a file system which is present in an operating system. Okay. If you face any problem, if you have it out, unmute yourself and you can ask me anytime. Okay. Because I'm getting sounds or disturbances, so I muted every one of you. Yes. Some examples of some file systems are Windows. If you are using Windows operating system, it's very familiar that you see FAT32, FAT16, DFS, even when you format your pen drive. Nowadays it's a very common operation that if something happens, we'll format the pen drive very quickly. There it asks the option, what is the file system, what is the file allocation unit. Okay? There you have to select the file system. Some file systems of Windows are FAT32. FAT it has version 16 and 32. FAT means file allocation table. FAT stands for file allocation table. And one more Windows based file system, that's a new file system, is new DFS, new technology file system. Similarly, when you go to Linux based systems, Linux based OS, we have file systems like ext series, ext, ext2, ext3. Currently they are using ext4 file systems. The matter is same, no matter what the operating system, no matter what the file system. The functionality is to arrange the bits, bits physically on a hard drive according to that operating system. According to the convenience, they will frame the file system, they will build the file system. That's where file system importance, file system lies is. Okay? But there are positives and negatives for everyone in the world, everything in the world. Even file system has some negatives, drawbacks. And see, there are lots of drawbacks, like the file system doesn't allow the Windows, for example, Windows file system DFS, which everyone using now, doesn't allow the naming convention beyond 256 characters. You type and see the name of any file more than 256 characters, it won't allow. And it won't allow some special characters, asterisk, slash, something like that. Those are common for everyone, but let's talk about the drawbacks with respect to Hadoop. Okay? The first and foremost drawback is storing large amounts of data. Is it possible to store huge amount of data in a single system, single file system? In a single system, we are talking about the normal file system which is present in our machines, laptops, desktops. All these machines are not connected to a network. They are single machines. Either it's a laptop, it's your office desktop, or your personal desktop. It doesn't connect. It never connected to network. Keep that in mind. So is it possible to store very huge amount of data in such systems? Can we store such huge amount of data? No, we cannot store. Yeah. By the limit of the
physical our
exactly physical system, physical hard drive, physical memory capacity. It depends on your physical hard disk. Maybe if it is 500 GB, that's it. Maybe if you are using high-end 1 TB hard disk, up to that only you can store. You cannot store. And the second thing is processing such large amounts of data. If we cannot store such large amount of data, how could we process? Even if we store the data which is exactly as much as our hard disk capacity, processing will also be a burden at that time. Suppose you have 1 TB hard disk and think that the total 1 terabyte is filled with large amount of data. Then then assume the behavior of your system, how your system laptop behaves. It will become heated up, it will become, the CPU usage and RAM usage will be very more. You can observe it in task manager. So there are lots of overheads in processing such kinds of data also. Processing such large amounts of data. Okay? All these are considered with respect to a normal file system. And data loss, here where the major factor comes. Data loss, how could data loss happen in normal systems, normal laptops, normal machines? What are the scenarios in which you lose data? Any brief idea, one word answers? Okay, I'll continue. There are certain reasons for data loss in a normal systems, normal file systems. Maybe it's due to power failure, network failure, hardware failure. Okay, maybe due to any of these reasons. Yeah. But of course, this can be overcome nowadays. Power failure we can manage through UPS. Network failure we can manage through another network, backup network also. And hardware failures, we can manage this one also with respect to RAID technology. Have you heard about the RAID technology? RAID, RAID. Redundant Array of Inexpensive Disks. This is a famous mechanism followed by lots of companies and everyone in order to overcome the hardware failures, in order to overcome the data loss due to hardware failures. That's a mechanism, like technology. They will use redundant array of inexpensive disks. They will use a lot of hard disks instead of one, so that the data is backed up into one more disk like that. That's a different technology with respect of ours. And one more is metadata. The most important thing related to Hadoop. Let's see, what is metadata actually? Any brief answer? What? Metadata. I can't hear you, Babu. Metadata. Just one word answer. Information about?
It gives information about other data that is being stored.
Yes, other data in the sense data about data. Yeah, data about data. Suppose if you have a audio file, there should be some data associated with it. That data about the data is called metadata. Suppose think of ours only. We have physical presence in the world, but we have some data. We have some government related data, unique data by which we can identify. like our CC Aadhaar card or like our DNA data, our address where we present, all this represents to us. That data is called as metadata. What kinds of metadata do we have in a file system normally? In a system, any kind of system, what kind of metadata for any files or directories that we store in our hard drive? Just expect it, don't tell to me, but just think of that. Suppose if you have an audio file in your system, what will be the actual file and what will be the metadata? I'm missing some things here. You just read up this. You don't bother about the first two, number of blocks and starting block location. Starting block location file size. Just leave these two. We will come to know further. And read the below lines. Creation time when the file is created. Last accessed when it is last accessed. Last modified when it is modified last. And the owner of the file if you have more than one user in your laptop. It also has owner information, group to which it belongs, permissions. If there are multiple users and if you created the file, you can set permissions to a file, who can access, who can read, who can execute, who can modify those permissions, all those related to metadata. All these are stored inside another table, metadata table, that which is present in each and every file system. And some attributes like read only, executable, as I said. Okay, following? Yes. And are there any things apart from this? Are there any things which comes to metadata apart from this? Just guess. Guys, I want you to interact, please. It's not like testing. You have to think. That's what my intention is. Yes? Okay. No, I'm unmuting all of you. I want all of you to see. Suppose I have given you a book. There are 4 participants in this meeting. I have given each of you a book which consists of 1000 pages. Okay? And I want you to open chapter 5. What will you do generally? Yes, exactly. That's what my point is. Index. What does index tell about?
How many tables are?
How many?
The information
It will show that in the
Yes,
book.
sir. Okay. I think it's overlapping. Okay, you both of you are correct. I got your answers. Index is also a kind of metadata. Metadata is not limited to these only factors. Any factor which tells something about the data, apart from the actual data, which tells something about from the data is termed as metadata. Indexing is also a kind of metadata. Okay, again, from the very same book, I asked you to open a word. I want you to find a word, Hadoop. Hadoop is a famous word. So I want you to find a word, Hadoop, where it is located in that book. What will you do? From the 1000 pages book. Yeah.
Go back in the
Go back from who?
In the last we have this appendix, right?
Yes, exactly. You are on the track. But if it is not a famous word, Hadoop, I have given you the Hadoop book, okay, it will be present in the appendix exactly. But I want you to find a word which is not a famous word. Appendix consists of only famous words. Only the words which are most redundant in the book. How about the words which are least occur, that occur very least, very low? Suppose I give you the word Yugoslavia, country name. think that it is present in one of the 1,000 pages in the Hadoop book. It won't occur mostly, right? In Hadoop book Yugoslavia. So I want you to find that word. What will you do? No other way. Simply you have to turn each and every page. 1,000 pages until 1,000 pages. Until you find the word, you have to read each and every page and you have to find. That's the only way. Why? Because it doesn't have content level indexing. You just try to understand. We have the index of the chapters and subchapters in the starting of the book. That is normal indexing. But we don't have the indexing related to the content of the chapters. Do you have any kind of index regarding that? What are the words present? What are the lines present in chapter 5? In chapter 6? We don't have any such index, right? That is content level indexing. If you have index, appendix is a kind of content level indexing, I agree, but it is not a complete level indexing, complete content level indexing. It's a kind, up to some extent, up to some most repeatable words, it's okay. The most interesting and the most dangerous and the most cautious thing is content level indexing. Because of this only, Hadoop, we can achieve this. We can achieve this through Hadoop, whereas in normal file systems we cannot. Suppose that you have a file name, like your file name something ABC file name, abc.txt. You have created it in hard drive, maybe it in a C drive, D drive, you have kept somewhere. And you go to the Windows menu, you type the Windows button and you search the ABC, give the file name. It displays wherever the file ABC is present, wherever the name ABC is present in the file. But if you give a word, if ABC suppose contains a word Hadoop, you type the word Hadoop, will it going to display the ABC file? It will not display. Are you following me?
Yes, sir.
Yes, it's only displays in general, our maybe it is a Linux system or it is Windows operating system. It has only normal indexing, but these file systems doesn't have content level indexing. Actual data what is present, they are not indexed. The data in normal file systems indexed only up to file level. This is a major drawback, but we can achieve this for content level indexing. See one example of content level indexing. Suppose you are you open google.com, Google search engine, and you search some data. I give one or two keywords. It is India, Modern, Bombay, something like that. Within no time, within less than 1 second, within milliseconds only, you are going to display, Google is going to display lakhs of results, right? How Google does this? What does the results mean? The results mean they are displaying the web pages which has that word Bombay. Suppose you search word Bombay in the Google, we are getting some lakhs of results, lakhs of websites which contain the word Bombay. As of I said now, I have word Yugoslavia in the chapter 5. So in order to find the Yugoslavia, one word you have to go through the entire book. But what if the same case with Google? If you display the results by searching the overall web content, if they display the results after 1 hour or 1 day, will you accept Google? Will you make that search? You won't make. So in order to get faster results, in order to get save time, we need content level indexing also, which is possible in Hadoop with a concept called inverted indexing. There is one important concept in Hadoop called inverted indexing. That part takes care of content level indexing, okay? You understood the difference between indexing and content level indexing? Yes. Any doubts so far clear? Yeah. Please feel free to ask, interrupt me anytime. I'm here to clarify you. Yeah, we have seen the drawbacks of file system. In the same way, let's go to distributed file system. Before going to distributed file system, you should know one word, cluster. What is cluster? I think everyone of you heard the word cluster. A group of systems connected to a network. Any network, maybe it is intranet, internet, anything. a group of systems. You can see, you can see the diagram there, figure there. Any number of systems, maybe 10, 20, 30, 40, which are connected to a network, which are connected to a centralized network. Okay, that idea, cluster?
Sure.
Yes, how to access a file in such a cluster, in such a network? Generally, what is the way? Suppose in your office, every system is connected to your local network, office network. Suppose there are 100 systems, 100 nodes. How to access a file which is present in your manager's desktop? How to access that file? Just think how to access the file in another system, in a distributed network. The general way is you should have the credentials. If you have the credentials, it's easy to access. Like host name, what is your manager's computer name, what is your manager's username, and your host name, your username. Host name in the sense machine name, and the username of that machine. IP address, target IP address, and the password of your manager. If you know all these details, you can easily know the details. Apart from that, your manager should have to share the file to you in the network. In that way, in both ways you can access the file. There are lots of some other ways too. This simply I am saying the introduction. This kind of network, this can have some advantages. Let's see what are the advantages of distributed file system. We have seen normal file system, now let's say distributed file system. Distributed storage, first one is. What is distributed storage means? In a normal file system, in a normal laptop, normal machine, you can store only up to the capacity of your hard drive, right? Apart from that, you cannot store. But in distributed file systems, you can store anything, like even like petabytes of data also. How? Suppose if there are 10 systems connected in a network, if your hard disk capacity is finished, if your hard disk is full, then you can store in another system, in system number 2, system number 3, system number 4, like that. These are the advantages. There is no limit for storage in distributed network. There is only limit for number of network nodes connected. And one more advantage is scalability. Scalability means scaling. You can add any number of nodes, any number of systems to that network. I'm saying high level only. There are a lot of constraints to add the systems, and there are limitations too. Please ignore that. In general, I'm talking about the file system storage especially. Understand?
With the scalability again, please.
What?
Scalability.
Scalability in the sense, Scale means you can keep on adding. You can add. Suppose there are 5 systems in the network. What will you say? There are only 5 systems. If you add 5 more, now what you will say? There are 10 systems in the network. Scalability means increasing. You can add. It is a property like that. See, reliability means how far it is correct. Like scalability means how far we go, how far it's supposed to add the nodes, how far it is supposed to increase the capacity of the network. If it increases the size of the network, then we can say that it is scalable. The network is scalable, right? Okay.
Okay.
Yeah. That's what scalability is. In distributed system, distributed network, we can add any number of nodes up. See, best example is your office environment only. Even if a new employee joins also, your administrator had to provide him a system. Simply adds that system to your network. Like that. That's nothing but scalability. Your network provides scalability. Like that. So, with that property, we can store large amounts of data. Now the entire capacity of the network will be the capacity what we can store. If we have 5 systems in a network, each have 1 terabytes of hard disk, we can store 5 terabytes. That's the capacity. In that same way, we can scale it. We can add any number of nodes. We can add any number, so much of data as we want. And distributed parallel processing. In a single system, if you are processing any data, that's up to your system only. But in a network, you can process the data simultaneously. Suppose you have a file name A in your system, and in your office, in your manager system, he has a file name B. You can process the file name A in your system. You can process the file name B in your system simultaneously, right? You can process all these files simultaneously. That is distributed parallel processing. Distributed parallel processing. These are the advantages of distributed file system. There are some challenges also associated with this file system. Let's see what are those. Storing large files. You might ask that just now I said that we can store huge amount of data, any number of data. We can scale it, the network we can add any number of nodes, and we can store huge amount of data. But now only I am saying that storing large files is a tough task. How it would be? You see the example here. We have 6 systems connected to a centralized network. Named that each one has N1, N2, N3, N4, N5, N6, node 1, node 2, like that. All these are connected to the network. This is distributed network. And this, each of this machine in this network is 500 capacity hard disk. They can store up to 500 gigabytes of information, right? Suppose you want to store a file which is 600 gigabytes. Are you able to store the file on this network? Can you able to store 600 gigabyte file in this network? Yes or no? No, right? Yeah, no. So it is a problem, right? You can add any number of systems. You can store up to any number of data as much as you like. But what if the file size is so large? File size is larger than a single node capacity. You cannot store. In that way, there is one solution, that you have to break the file. You have to split the file actually. You have to split the file so that you can store it in 2 systems. Suppose think that the 500 GB file, you have to split into 2 parts. One is 300 GB and another is one is 400 GB and another is 200 GB. In that way you can store, but it's very difficult to store. Splitting such a huge file accurately and storing it and maintaining the metadata where we store. I'll tell this factor in the next step. We can store, but it's very overhead. Processing such large file, 600 gigabytes of file. Even if we cannot store, how could we process such a file? Now assume the scenario we broke the file. We broke the 600 GB file into 2 parts, like 400 GB one part and 200 GB one part. Now we can easily store, right, in the system, 400 GB in one system, 200 GB in one system. Okay, we can store now, right? Yes, in that case, you can store and you can process 2, but we suppose after splitting the file, we are stored, and after 1 year, be able to remember which part you stored in which system. Where is the first part, 400 GB in which system you have stored, say, and 200 GB in which system you have stored? No, if a network doesn't have any traffic, if you don't do any work in the network, you can remember. But generally, after 1 year, you have a lot of modifications in the network, lot of works, lot of file names, lot of new file creations, deletions. In such scenario, after 1 year, will you remember where you kept the 200 GB part and 400 GB part in which systems? You cannot remember. You have to make a note somewhere. That note is metadata. You have to update the metadata. That I have placed the 500 GB, 400 GB part in this system and 200 GB part in this system. Here the metadata has to be updated by us. This operating system or file system, distributed file system, don't take care of this thing. Manually we have to update the metadata. What if the metadata is not backed up after updating? What if it is not updated? The whole file will be lost. If you forget to update the metadata, the entire file will be lost. There is no use of storing it. We don't know where we store the parts. Even if you update the metadata, if one of the system in the network crashed, if you remove that and you added a new system, the data then becomes inconsistent. What if the 200 GB part maybe is broken down? What if the part in which the metadata consists broke down? There is no reliability to trust these kind of systems. We can store, but storing large files which are huge in size is not possible. It's possible, but it's very overhead. Okay, got it? Yeah, this what I'm trying to say is I'm taking it step by step. What is a file system? The next generation of file system is distributed file system. What are the challenges in a normal file system, and what are the challenges in distributed file system? After this, I'm going to HDFS. See, assume one thing. You have 600. Right now, I told I have 600 GB file. You might think that will there be a 600 GB file? Nowadays, it's a common thing to have a 600 GB single file. We can have it. Yesterday, as I told, like satellite images, Hubble telescope images, they are in terabytes, not in gigabytes also. So we can have such huge kind of data, even though you can generate such data in your system, laptop, by simple commands. Okay. Now HDFS answers all these challenges. HDFS says, I am here. What are the drawbacks in file system? Inverted content-based indexing is not there. HDFS says, don't worry, I can make content level indexing also with the help of my child. With the help of my subpart, inverted indexing concept. With inverted indexing concept, HDFS provides content level indexing also. And when you come to distributed file system, you cannot store the very large file. HDFS says, no matter how large the size of the file, how large the file size is, throw it in me, I can store, I can take care of myself. HDFS itself updates metadata. We don't need to update metadata. That is the power of HDFS. HDFS is also a kind of file system. I'll tell you what kind of file system is. Hadoop follows distributed storage mechanism. First, let's see the features of Hadoop. See, why I'm skipping HDFS now is HDFS is a major part, and it is an important part. It takes around 1 week for us to complete. So I'm introducing you to HDFS. From tomorrow onwards, we will see one by one internals. We have read architecture, write architecture, everything we are going to see. Right now we are on the track, right? What is HDFS? What is the power of Hadoop and power of HDFS? How it differs from the traditional systems, traditional file systems, traditional distributed systems. Okay? Yeah. So let's see the features of Hadoop. It is fault tolerant. Fault tolerant in the sense, if you are in a distributed network, if you are storing file in one, if you are storing files in each and every system. So what if one system broke down? Unless until you take the backup, you have to worry. If you take the backup, you don't need to worry. But is it the right way to take backup each and every file? You can take, if it is important, you have to take, but it's overhead, right, to take each and every time backup. Whenever you upload a file backup in the network. It's overhead task. But Hadoop takes care of that. It replicates the data. It makes backup in the form of replication. If you upload one file, it stores in 3 places. It automatically stores. It takes care of it. Yes.
Replication means storage is, the storage level is increasing, right? So
yes, storage level is increasing.
So HDFS can store, the storage is increasing for HDFS.
Yes.
We can do the programming like replicate. We can reduce the replication, but here the replication is increasing. It will be difficult, right? I mean,
We can reduce the replication. Yes, we can reduce the.
what we want, right? We can write the replication. We can overcome the replication. I mean, what I want to tell you,
Mhm.
the duplication is, we don't want the duplication. But here the replication, and it is storing 2-3 levels with
Yeah.
2-3 storage, so it will
Yes.
take the memory more, right?
Yes, yes. It needs memory, lot of memory. The data is duplicated. But what if, see, in a normal distributed system, in a network, if you in your office network, suppose if one of the system is corrupted, one of the system suddenly it got problems internally and it backed up. If you don't have a replication of the data, what is the scenario then? You lose the data in that system, right? Here, in Hadoop, replication is there. Data is redundant. Data is present in general replication is 3. If you get a file, it replicates in another 2 nodes. Totally, there are 3 copies present. Memory is wasted, but Hadoop promises reliability. Even though 1 copy gone, even though if 2 copies gone, 2 copy of the data is gone due to something, any other faults, at least you present the 3rd copy of the data. Okay, Hadoop promises reliability. No matter what happens, your data is safe. This is what Hadoop slogan, Hadoop says. Suppose if you have 3 copies, if 1 copy is also damaged, 2 copies also damaged, Hadoop automatically replicates that damaged copies. With the help of the 3rd present copy, it creates another 2 copies. No matter what happens, your data is safe. Of course, hardware capacity needs larger hardware. That too, commodity hardware. Commodity hardware, Hadoop uses commodity hardware. Means the hardware which are available cheaply. It doesn't need lakhs of rupees. In normal cheap hardware it uses. So that is the reason.
Interlink between those 3 storage spaces?
Yeah, is there interlink in the sense what kind of interlink?
I mean, one data is storing in 3 different storages, right?
Yes,
So,
yes.
it will check for first level, and if there is no, if we didn't find in first level, then it will go to second one or the third.
No, not that. You have to wait 1 or 2 classes in order to clarify that.
Okay.
Okay? I will tell you a doubt. I will give introduction to your doubt in the ending of this class. So actually, we need to look the architecture in order to clarify your doubt. I'll give introduction now. See, let's see the remaining features. Flexible, any kind of data. I told that fault tolerant. The data is replicated and it is scalable. We can add any thousands of nodes in Hadoop. There is no limit. Flexible, any kind of data in the world, you can fit it in Hadoop. Hadoop stores it. Cost effective. Hadoop doesn't require any money. It is an open source. And faster processing. After storing such huge data and after making replications copies, what's the greatness if it doesn't have such proper processing mechanisms? So Hadoop also promises that I will give you results faster because I have my talent MapReduce. It uses MapReduce concept to process that stored data. It will map the data first. Just see this, map the data and process the data and aggregates the data. As of now, just remember this verse. Nothing more than you will confuse. We will see deeply in the architecture, MapReduce architecture. And secure. It stores large amount of data. It processes very huge amount of data quickly. But what if it is insecure? No one uses that. Hadoop also provides security. Internally, Hadoop has a security concept, SSH, secure shell concept. And externally, we can also implement. If SSH is not sufficient for us, we can use Kerberos. Have you heard Kerberos? It is a powerful network authentication protocol developed by MIT students. It's very popular. We can add that security mechanism to Hadoop also. See, HDFS take care of storing, replicating, metadata management, processing, everything. Unlike in distributed management system, we don't need to update the metadata. If we split the data, just power of Hadoop is you just copy the data into Hadoop as an end user. How you copy in Windows, like copy and paste. Just copy and paste like that. Backend, it sees backend, everything it takes care of itself, like storing, replicating, where to replicate, like every factor, metadata, everything it takes care. Let's briefly see the process names of Hadoop. You see this figure? Hadoop, as I told now, right now I'm telling about Hadoop version 1.x. I didn't include Yarn in this. Okay? Actually, Yarn comes in between this. Are you seeing here? Wait, where is that? Just a second. I need to mark, okay? Actually, Yarn comes here. This is the layer for Yarn. It is on top of HDFS and below the map reads, in between here. Just now, as of now, neglect Yarn. After completing map reads, we will see what Yarn is. See, Hadoop internally, HDFS, it is related to storage, and map read is related to processing. There are certain processes in Hadoop which you need to know. Certain terms: name node, data node, secondary name node. When it comes to processing, job tracker, task tracker. Okay? There are 5 important processes in Hadoop. Everything in Hadoop is taken care of by these things. And RPC port, there are some ports in order to communication. RPC port and HTTP port. RPC port means for internal communication between these systems, between name node to data node, it uses RPC port 8020. And between job tracker to task tracker, if these processes want to communicate between themselves, then they use the port 8020, these ports. That's what RPC port is, remote procedure calls. And this job tracker uses 8021 port. What this HTTP port means, if you want to access the data in Hadoop through a browser, then we will access the data by giving our host name. After that, this port name. To access the data in HDFS, we use this port via browser. If you want to see a particular data node, you use this one. If you want to see a secondary node, you use this one. Okay? Now, what is a name node, and data node, secondary name node? You see this figure. This is a typical layout of a Hadoop cluster. Typically, a cluster looks like this. Everyone seeing this now? I cannot find this. Yeah. Now see, just try to understand. I told 5 processes previously: name node, data node, secondary name node, job tracker, task tracker. Where each of these are located in this cluster, Hadoop cluster? Just try to observe. Name node, secondary name node, job tracker. There is one word called master. These 3 are called masters. See this: name node, secondary name node, job tracker. These 3 are called masters. And the remaining 2, task tracker, data node. Task tracker, data node, task tracker, data node. These are called slaves. See, in a typical Hadoop cluster, you will have one name node. You can see here, right? You will have one name node. You will have one secondary name node. And you will have one job tracker. Okay? And you can have multiple data nodes. And you can have multiple machines. Are you following? Yeah, see, this is Hadoop. Hadoop cluster is also a network type. But the only difference between normal networks and this is, in normal network you will have a server, right? Suppose there are 100 systems network. For that 100 systems, you will have a single server to allow the outgoing traffic and to allow incoming traffic. In the same way, Hadoop cluster also has the masters. Suppose the cluster size is 10,000. We have 10,000 different systems in the cluster, 10,000 system cluster. Apart from that 10,000, we will have a name node, we will have a secondary name node, we will have a job tracker for that entire 10,000 cluster, and the remaining 99,997 things are data nodes in which we store the data. Okay, we store the actual data here in the remaining parts. Okay, but how about these three? What these three things do? What name node do? What job tracker do? What secondary name node do? As I told now, name node, just now we discussed about the metadata, right? So far, that metadata is taken care by name node. Name node takes care of that metadata. It takes care that where each and every piece of data is present in the entire network. What is present in data node 1, in data node 2, in data node 3, data node 4. Everything, every information is present in name node. It has the metadata of the entire data present in the Hadoop cluster. Okay? Understand? Yeah. And the secondary name node means it the secondary name node purpose is to store backup of this name node. This name node is a single machine. Here single box, you can find single box, single box, single box. These three machines are stored in a single machine, only. One machine is dedicated to name node, one system is dedicated to secondary name node, one system is dedicated to job tracker. So name node takes care of the metadata. But what if name node system fails? We need to have a backup. That backup is taken by secondary name node. Okay? Okay, clear guys? Yeah. And I pointed an arrow here from secondary name node to name node. What does it mean? Means name node just maintains the metadata. It's the job of the secondary name node to collect the metadata from name node on a hourly basis. It collects the metadata at 7 o'clock from the name node. Until 8 o'clock, it keeps on collecting. At 8 o'clock, it merges the previous metadata with the present 1 hour data, and again it gives back to name node. Secondary name node, it takes care of the maintaining the metadata, backupping the metadata. Suddenly, even if the name node fails, suppose that due to any failure name node goes down, secondary name node is there. Our metadata is not lost. Simply we can add another system, we can configure the name node in that system, and we can connect to the cluster. Within seconds, our cluster comes up suddenly, without any loss of data. Okay? Yes. When you come to job tracker, of course we are storing this huge amount of data. We have to process it also, right? So as an end user, you use some commands, you write some MapReduce programs or high queries, anything, processing commands. You just give these processing commands to name the job tracker. Job tracker means job work. It will take care of the whatever processing mechanism, whatever jobs we are getting from outside, whatever jobs the client gives to the cluster to perform. Everything is taken by the job tracker. The main functionality is to take care of the jobs. It is responsible to collect the jobs from the client and to process. Actually, it won't process. It is just, remember, it is responsible for the jobs that are given by the client, the work that is given by the client. It will take care of that, managing only. The actual execution will happen here. If I tell everything now, you will get confused. Just see the outline of the Hadoop cluster. Name node for metadata, secondary name node for backup of metadata, job tracker takes care, collecting the jobs from the user, and there are slaves. These are masters and there are slaves. This entire blue one refers to a single system. This is a single system. This is a single system. This is a single system. Like that, You can scale up to any number. Right now the Yahoo is in 42,000 node cluster in series. They are connected, they are maintaining the data in 42,000 systems network, like that, 1, 2, 3, like that. So they are maintaining 42,000. You can scale up to any number of, based on your requirement, based on your storage requirements. Now let's see internals of the single system. The single system has two components, task tracker and another is data node. Actually it is called a data node 1, data node 2, data node 3. Okay, you see in this figure, what is this job, you see data node you can find, right? Data node and task tracker. This is the data node. This is the data node. This is the data node. In a system, data node is nothing but memory simply. It stores the actual data. Name node is responsible for storing the metadata, right? But where the actual data is stored? Actual data is stored inside this data node, inside this system, inside this system, inside this system. Here, where the actual data is being stored. And task tracker, in each and every system, we can store actual data. See, this is data node, data node, data node, data node. In a data node, there is task tracker present inside. In data node, we can store the data. See, this is actual data where we are storing the data. In a data node, we can store the data. And the processor, just as of now assume that task tracker is the processor of the data. CPU of the data node. It is a system. It has memory. Memory is data node where we store the data, and where we process the data is task tracker, this one. Okay? Fine? Yes. Once again, see high level. Name node, secondary name node, job tracker. And in each single system, data node, task tracker, data node, task tracker, data node, task tracker. Data node is responsible for actual storage. Task tracker is responsible for executing the jobs. See here, there are some arrows I have pointed. Task tracker is contacting to job tracker. Task tracker is contacting to job tracker. And this one, data node is contacting to name node. This arrow, data node is contacting to name arrow. It means whenever a job is submitted by a client, job tracker takes care of the job. It resolves what is the job. Okay, it says, okay, some client has given me a job, I have to execute it. So it gives, then it then passes the job to task tracker. Task tracker is the thing where actual jobs are being executed. Task tracker, task tracker, task tracker. I don't want you to go very deeper into in this architecture. If you are confused anything, just forget it. Just remember that name node for storing metadata, secondary name node for storing backup of the metadata, job tracker to manage the jobs, to connect the jobs, and you have a data node like thing. In that data node, you will store the actual data, and there is a task tracker present in each data node. In each data node, you will store the data, and there is a task tracker. You will store the data, there is a task tracker. Task tracker is responsible for executing the tasks in that machine. Just remember this. Don't remember everything else. If we go deeper, we'll be going to architecture only. It's not the time to discuss the architecture. Okay? Yes.
Okay.
I think it's 10 o'clock. We should stop now. There is one more thing, but we should discuss it tomorrow. Let's see what is block size, everything that. And Deepti, is it you asked regarding replication? Some doubt?
Yes.
Yeah, can you repeat once again?
I mean, there is any interlink between those.
Yes. There is internal in the sense Hadoop frameworks take care of to replicate the data. Suppose you have a file size, think 10 MB file size you have. You kept in the HDFS, you gave the Hadoop to store it. Hey Hadoop, please store this file. You told to Hadoop. Okay? Hadoop, what does means it takes that file, It takes that file and first it writes into one of these data nodes. Hadoop first copies the file. Hadoop first writes the file, 10 MB file from your local system to Hadoop cluster in one of these data nodes. Maybe this one, maybe this one, maybe this one, maybe this one. It depends on the space availability of these machines, individual machines. Suppose you describe the data node 1 is, there is no space, even there is no 10 MB space in the data node 1. It goes to data node 2. It writes one copy there. It writes one copy there.
Okay.
Another second copy and third copy we should write in the remaining systems. Suppose second copy is here. Suppose you think here. And the third copy is here, you think. Okay?
Okay.
Now, your doubt is, what is the interlink between these 1, 3, 2 copies, right? There is no interlink between, there is no link between these copies. These are just slaves. These copy 1, copy 2, copy 3, just resides on the data node. That's it. But the link is here. The link is here. Name node has the ID of the copies. Copy 1 is in the system here, in the system data node 2. Copy 2 is in the data node N, and copy 3 is in the data node 3. This information name node maintains. That's what metadata is. Where the first copy, where the second copy, where the third copy is present. That information is a part of metadata. That is maintained by the name node. Apart from that, these copies are not interlinked. Copy 2 with copy 3 doesn't have any link. It doesn't even know that copy 3 in this system, copy 2 is in this system, copy 1 is in this system. Each and every copy, they are just like toys. It's your part. Suppose I give you 3 toys. I wanted to place you in 3 rooms. In the one available 10 rooms, you place the 3 toys. Toy 1 in this room, toy 2 in this room, toy 3 in this room. It's up to you to keep where it's your wish. Where you keep, that's your wish. But do those toys have an interlink? Does toy 1 know that toy 2 is in 5th room, toy 3 is in 10th room? The same way, there is no interlink between these 3. But their metadata is present in the name node. Name node, that's what the name node job is. Where is each and every block present? Okay? Clear now? Yes.
Is there any, we can specify which many copies we should store in Hadoop cluster?
This many copies in the sense, now I said 3 copies, like that.
Yes.
Yeah, the default is 3. If you install Hadoop in your system, the default copies is 3 copies it will take. But we can vary that. Hadoop gives that power too. If you don't have any sufficient hardware, you can make the copy as 2 also.
Okay.
And if you think your system's network is very, very secure, even if you place a hydrogen bomb also, your cluster won't have anything, then there's no need of replication. You can give the 1 replication minimum. You don't have any replication. If you don't need any replication, you can do that also. Minimum replication is 1. Minimum 1. Maximum is 512. You can make 512 copies maximum. Here 1, 2, 3 are given, right? In this way you can make 512. Maximum 5. Minimum 1 to maximum 512. That Hadoop allows. Yeah, default is 3. All 3 is recommended by that framework, so the default is 3. Okay?
Okay.
Okay, that's it for now. Tomorrow there is one thing left. We have some more block size and replication. Replication I said you, but I will say the alignment. It takes some more time. Let's continue this tomorrow. It's already 10:05. Okay?
Yeah.
Yeah, we will see this tomorrow. Okay, guys. Any doubts so far?
No.
Everything clear? Yes. Thank you. Thank you very much. I'm ending the meeting now. Okay, one more thing. Hello. Have you all installed Ubuntu?
Yes.
You install it in a dual boot mode. Dual mode. You know dual boot mode, right? Have you seen the video given by me? Installation of Ubuntu.
Yeah.
Yeah, you better install Ubuntu, because in 1 or 2 classes we're gonna install Hadoop also. Tomorrow not possible, I think. Maybe after that day. Day after tomorrow we have to see the installation process. So it's better to install Ubuntu right now. If not, do it today, please. Okay.
Okay.
Okay. So let's conclude. I'm ending the meeting, right? Okay.
Okay, sir.